Okay, so negative 1 squared is 1, 2 minus 1 is 1, this is 1. Alright, so now I'm going to do negative 1, 3. So that's 1 times 2, or 2. So then we want to just make sure we make it clear that, like, if I would go backtrack, kind of, that we make that a steeper slope. How about at 0, 3?
2.
No, 0, right?
Oh, sorry. Yeah.
And then the last one at 1, 3 is 2 again. Okay. Alright, so there's my slope field. Okay, so it says, while the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Describe all points in the xy plane for which the slopes are positive. Okay, so let's think about this. In general, dy dx would be positive when this expression is positive. Okay, tell me about x squared. X squared is always positive. So in order to answer this question, I would need to find where is y minus 1 positive. Okay, so as long as y is greater than 1, then the slopes are going to be positive. And also, what else cannot be true? Because let's say this was positive, what number would this still not, yeah, and I'm going to say an x cannot equal 0. So I'm going to write for y is greater than 1 and x is not equal to 0. Does that make sense? Alright, now, yay, we're going to find the particular solution. So, I like these. Typically, like, at least 5 points are assigned to these kinds of problems, okay? Couple things. They will award you no points if you don't separate the variables. Like, you'll get nothing. If you try to, like, integrate both sides or something. So you always have to start these by separating the variables. Put the x with the dx, the y with the dy. So, let's move this y minus 1 to the other side. Wouldn't I divide by y minus 1? So I'm going to rewrite it as 1 over y minus 1 dy. And over here, I'm going to multiply both sides by dx. Okay. Hopefully you're seeing this is kind of something, this is going to be a little harder, but this is like similar to the one we were just working with, because if 1 over y, if the integral of that is natural log of y, if it's 1 over y minus 1, it's just going to be the natural log of y minus 1. Okay.
But wouldn't you have to do like the d thing too? Never mind.
As long as these match. That's why we had to separate the variables. What's the integral of x squared?
X cubed.
Yep, or 1/3 x cubed. Remember, there's going to be a plus c and a plus c, so okay. Is the y value that I gave you, we already talked about how the y value would have to be bigger than when y is greater than 1, right? Okay. Is the y value I gave you greater than 1?
Yep.
Yeah. So I am going, because of this particular solution, I don't have to do the plus minus in this one. I can look at what I was given and I can just pick the positive. So I'm going to drop that out and rewrite it as natural log of y minus 1. And I'm going to draw an arrow up here, because we know that that value is going to be greater than, or make it positive. Okay. So, in the last one, I did the e first and then I found the constant. Let me show you, you can do either way, but let me show you if I tried to find, I have an x and a y, right? Is y alone yet? No, but I still could find c at this point because it might involve a little less algebra. So what I'm going to do is I'm going to plug my point in 0, 3, and I'm going to try to see if I can figure out what c is. Okay? So I plug 0, 3 in, so I have the natural log of 3 minus 1 equals 1/3 0 cubed plus c. What happens here? Cancels out. So it looks like the natural log of 2 is equal to c. We doing okay? All right. So now we're going to go back and put that natural log of 2 in and write our equation for y. I'm going to go right back here. So I'm going to rewrite natural log of y minus 1 equals 1/3 x cubed plus natural log of 2. Do you remember what we did in that first example to get rid of this natural log over here? Yep. So we're going to do e to the natural log of y minus 1 over here, and e to the x cubed over 3. And do you remember my trick? Times e to the natural log of 2.
How can you multiply it if it's adding?
It's a power of e. The in-between step.
The whole thing was e.
Okay, this is the in-between step to this. Okay, if we have addition and a power, you can rewrite it as e to this times e to that. All right, so what happens here? Well, you get y minus 1. What's e to the natural log of 2? 2. All right, one more step. How do we get y alone? So that, did I write squared? That should be cubed. No, I wrote cubed. Okay. I am going to, at this point, just point out to you, if you go back to the example we did, you see how I put the constant in earlier? Not the constant in, the point in earlier to find c? You could have done that in the other example we did. What you would have gotten is the same thing. You would have gotten e to the natural log of 1, and then the 1 would have come down. So, either place where you put it in, you should get the same equation. What do you think? Kind of weird. All right, we're going to save